hydraulic drive units which convert hydraulic energy into linear motion. These are the cylinders. Rotary drives, or as they are also called, hydraulic motors, generate rotary motion. Let's look first at hydraulic cylinders. The single-acting cylinder. This is a single-acting cylinder and its circuit symbol. It has one port for a working line. And this is how it works. When oil flows into the chamber, working pressure builds up and the piston advances. The cylinder can do work in only one direction. Even when oil pressure drops, nothing happens. The piston doesn't retract until an external force is applied. Incidentally, the piston doesn't seal off the two cylinder chambers from each other 100%. This is why over time some oil does get into the unpressurized chamber. This oil then flows back to the reservoir via a leakage oil line. Here we see a single-acting cylinder in a scissor-type elevating platform. The return stroke is powered by an external force, in this case the weight of the platform. But there are also single-acting cylinders with spring return. This cylinder, which creates contact pressure as it advances, is returned by a spring. The single-acting cylinder in this scissor-type elevating platform is a so-called plunger cylinder. Here the piston and rod diameters are the same. This design is extremely bend-resistant, which makes it particularly suitable for moving heavy loads. This is why plunger cylinders are often used in platform lifts. The double-acting cylinder. The double-acting cylinder can be recognized by its two working ports. This is how it works. Pressure is applied to both sides alternately to advance and retract the piston. This means that the cylinder can do work in both directions. It can push and pull. The cylinder retracts faster than it advances. Just why is that? Well, here we can see why. The chamber on the rod side is smaller, with the rod further reducing the effective rod surface area. In actual practice, cylinders are often used in which the ratio of the two piston surfaces, and thus of the chamber volumes, is precisely set at 2:1. Such cylinders are called differential cylinders. From this we can derive the following. If force F1 equals P times A, and force F2 equal P times A over 2, then the force on the return stroke is equal to half that of the advance stroke. On the other hand, the flow rate being equal, half the chamber volume on the rod side is filled with oil in half the time, so the piston retracts at twice the speed. The flow rate of the discharged oil is also twice as high because double the amount of oil must be discharged in the same time. This causes back pressure to develop. These laws must be taken into consideration when choosing hydraulic cylinders. In this special cylinder for a press, the piston rod has almost the same diameter as the piston, making the difference between the two piston surface areas extreme. This means that a slow flow rate is sufficient for relatively fast retraction of the piston. Varying piston speeds would be undesirable in this hydraulic steering mechanism because steering movements to the right and left must be at the same speed. For this reason, a balance cylinder was used in this case. A balance cylinder is one with a double-ended piston rod. An additional advantage of a rod like this is that it can move elements on both sides. A hydraulic cylinder with a long stroke and a relatively short length is the telescopic cylinder, which comes both as a single-acting and a double-acting cylinder. And now to hydraulic motors. Basically, they function just like hydraulic pumps, only the other way around. The hydraulic oil, which is under pressure, drives two intermeshing gear wheels. It flows along the chamber wall and becomes almost unpressurized because it only has to overcome line resistance as far as the oil reservoir. An important characteristic of hydraulic motors is the consumed volume V. This is the quantity of oil that the motor can take in one revolution. Rotational speed N is calculated from flow rate divided by consumed volume. Any calculations of hydraulic systems must always make allowances for leakage oil loss. This hydraulic motor, which drives the trolley of a gantry crane, converts hydraulic energy into mechanical energy in the form of rotary motion.